We're going to talk about empirical formulas. And the empirical formula, you should already have got the definition down. If a compound gives the lowest total number ratio of atoms or moles of the elements in the compound. This is probably the hardest thing we've talked about in this chapter. You need to write down the steps. You need to take those steps and do those exactly like I do them on board in your groups. So for example, what's the difference between an empirical formula and a molecular formula? We have H and O is the empirical formula of hydrogen peroxide. The actual formula of hydrogen peroxide is H2O2, as you see here in the notes. And so I can compare the two. If we go here, if I have H2O2 versus, all right, what have we done? What's the difference between the two? We've simplified. What did we take out of this one? Out of this one, what did we take out of the subscripts? 2. So in this one has been reduced by 2, and so this is the lowest whole number ratio between two subscripts. This is 2 to 2. That is 1 to 1. And so the lowest whole number ratio is what we call the empirical formula. It's been reduced the most. Okay? The actual formula, now notice we call this molecular. Now that term should mean or it should indicate to you that you're dealing with a covalent compound. Ionic compound, when you're dealing with ionic compounds, their charges will reduce themselves. They will cancel, okay, and reduce. Molecular compounds, which means you have 2 nonmetals, we can't say the same thing. And so what we have is that with molecular covalent compounds, you can have a combination of numbers here for subscripts that are not reduced. And so the one that is not reduced is called the molecular formula. The one that is reduced, the CH2, is called the empirical formula. So you can't really see that. That's right. The molecular formula then, which is one that's not been reduced, equals to the empirical formula reduced by some number n in the subscript. So if you have this on the SOL, C3H9, okay, that would, or could be reduced to CH3 taken out of 3. And so I can see the SOL question where they give you a molecular formula and they say which of the following answers is the empirical formula. And so you have to reduce it yourself and see which one matches. Let me just do a couple here. So we have C2H6. We have something like P3O9. Give me the answers that the SOL would have that said which of the following is the correct empirical formula. Anybody do that? Okay, Jim.
The first one would be CH3.
Good.
And put that in parentheses and then a 2.
Okay, that's fine. CH3 is the actual molecular empirical. That's right. You don't have to have you don't have to put the parentheses with the 2. This part is the empirical formula.
I mean, can you though, and it's still?
Well, you can, but the answer is CH3.
Oh.
Okay, so what's the answer here?
PO3.
PO3 taken out of 3, right? Okay, now we can flip that question and turn it around and say, give me a possible molecular formula for that. Give me a possible molecular formula for that. Ms. White?
C3H9.
C3H9. Okay, all right. And so if we have this one, C2H, oh, so do that one. That one won't work. Let's go with this one, C2H3. A possible molecular formula would be C4H6. Okay, all right, cut it a second.